Good afternoon and welcome to Actionable Intelligence with Utility Data. Before I introduce today's speaker, I want to make sure everybody's familiar with the platform, just in case you haven't been on the 20 other sessions that we've already had. On the right side of your screen is a chat and Q&A area. Please use this chat to have open dialogue with us or the other attendees. These are specific to each session. If you have a question for today's presenters, please post those in the Q&A section so we can keep everything in one place. We will answer as many of those questions as we can when we get to the end. All sessions are being recorded and they will be on demand within a matter of hours. If available, you can find any relevant downloads just below this main presentation area. You can scroll down and download those there. Your speaker today is Giovanni Polizzi. He is the VP of Sales and Marketing for Minsait ACS. He's an experienced energy industry professional with a degree in aerospace engineering and a postgraduate diploma in renewable energy technology. He's collaborated with the energy sector to shape the utilities of the future, and he's consulted internationally on IT systems, smart grids, transactive energy, industrial IoT, distributed energy resources, and conventional power generation. Assisting with the Q&A segment is Leonor Gonzalez, Project Manager for Optimization and Analytics at Minsait. Now that that's out of the way, Giovanni, you want to get to the good stuff?
Thank you, Delena, and thank you to our audience. And also thank you to Leonor because it's pretty late in Spain where she's connected. So thank you, Leonor. Leonor is it's an important part of what we're going to speak about today. She leads the intelligence group at Minsait, so she's behind all the algorithm, all the forecasting, the clustering that we're going to talk about today. So this presentation is basically just trying to explain how a utility data that is already available in the utility can be used to take action and to improve the business of the organization. So let me start by saying we're talking about technical data today. So basically technical data analytics. A few use cases that Onesait utility intelligence can cover. We will see today clustering analysis, load forecasting analysis, hourly overload of distribution, for example, anomalies, reviews, and non-technical losses analysis. We can locate and identify performance deviation and the exceptions that the power flows can show during the operations. We can determine patterns of demand profiles and aggregate different network points. So from the meters going up to system level. And we can analyze the performance of grid assets and of processes that are associated with grid operation. Onesait utility intelligence basically performs 4 different functionalities. One is the collection and processing of data, so real-time data and data pre-processing. It's got an engine, and we are able to stream data in the system and analyze directly, for example, comparing with thresholds, compare with sudden increment or decrement of one of the measures. We can take digital signals as well as analog signals. This is everything. When we're talking about collection and processing of data, we're talking about operating efficiency. So we're trying to get as close to real time as possible to immediately notice or to immediately be alert that something is not as expected. And the second piece is the storage. Of course, we store data, real time and historical database, so we can import data from existing historic data, and that is very useful for the next step, which is the analysis. So as the data scientist, where Leonor plays a role. She analyzes, she runs algorithms, she teaches algorithms, she trains algorithms from past data to forecast what's going to happen in the future. It's a multi-language environment, so there is different possibility to write code. And then there is the business vision. So that's a set of dashboards, reports, and notification through texting, for example, through emails or through web pages. So we're going from an operating efficiency to a business profitability. We're trying through analysis to forecast things before they actually occur and to understand basically to take action before things occur. We represent here the data lifecycle. Everything that is within that bright blue frame, this is the system we're going to talk about today. Actually, the administration part is also in my bad. I should have been a bit lower. Also the administration part. And you see here the different components that make up the platform called Onesait Utilities Intelligence, which are the collection part, the reaction part, where we do data pre-processing, the organization part, this is the story that we saw before. We call it learn, the part of analytics, that's where we learn things about the business. And then when we improve things by visualizing the effect. We don't expect that everything that is analyzed in the platform actually has an immediate interaction with the user. So we don't expect user to be constantly looking at this, but yes, to be notified when things are not as expected. And then the administration piece that we see here, a very important part, because you may find similar platforms out in the market, and you will have all these different elements as separate elements integrated somehow. We have managed to wrap everything inside one single application called Onesait Utility Intelligence, and the administration tools allows administration of security, users profile, access to data, configuration of every single component of the platform. So very easy to learn, very easy to maintain from an IT point of view and from a user point of view. Let me go to the next one. We talked about data. So which data? This is a simple representation of what we mean by data. On the top side here, we represent, for example, everything that is technical. The substation, feeder data coming from SCADA, breakers, regulators, or IoT devices that you have already in the network. There are already a number of IoT devices, for example, that are measuring voltage along the network and measuring power factors or power quality in general. We have weather data, so historic and, of course, forecast data. And we have demand data associated with ME90, AMI, for example, PV and storage data coming from customers and from commercial industrial customers' premises. We represent everything as going within Onesait Intelligence, and then anything, basically any department in the company can be provided with this information. Of course, data analytics, engineering and planning, data visualization, knowledge and sharing, for example, for training, to train people on effects in the network, to create alerts, to generate workflows, to provide information to work groups that are working together to solve a problem or to address an issue that has been identified in the network. So all these participants become important when we deliver the information. This, of course, means that when we talk to clients, sometimes we talk to SCADA, to the SCADA department, right? But also other people. Normally, other departments are involved in this in the use of Onesait Utility Intelligence. It's longer to capture the value of such a platform within an organization. But the value delivers is so much more when more than one department have a view of what this application can do. And so let me jump to the use cases. And please, if you have any question, put down the questions in the Q&A, because we can. If you want some very technical question also about the algorithm that have been implemented, Leonard will be more than happy to answer your questions. So let's see the use cases. Some of you will probably have seen our demonstration of Onesait Intelligence, and you've seen how we are leveraging SCADA data to improve operation, like to have better operational insight. We're taking data to analyze how substation transformers are doing, to notify about overloads, hourly load, understanding the fleet load across the entire number of transformers that are in the network. We also have a more traditional way of looking at voltage profiles, currents, power factor, for example, in bus voltage across the network. You've seen this coming from aggregated information, for example, a system level in terms of kWs, down to circuit level in terms of voltage, current, even current per phase, or power factor. This is one of the use cases, probably the most immediate. So it's like a very evolved historian, but also a very important information in terms of aggregation of information. The next use case that we're going to see is something that is very very much related with the SCADA when you want to provide this information outside the SCADA network. For example, a GNT may want to provide this information to their members in terms of the circuits that are being fed by the GNT organization. This case here, it's very simple, but it's an indication, of course, of what can be shown, right? This is a substation with the different circuits coming out of the substation. So each one of this is actually being fed with real-time information. Something different is here. It's a representation of, in this case, it's a switchyard in a power station. Again, if you have people in the field that need this information in real time, that's a very good way of showing this information through a tablet, for example. And bear in mind, all the symbols that you see here are symbols that can be configured, can be customized, so that whenever, for example, if you have a number of symbols that your organization normally uses, then this could be a way of normalizing the representation. So basically, you create a library of symbols, and then those symbols are representing all your diagrams. So think about any circuit can be represented this way. It's a very easy, very handy way of representing SCADA displays outside the SCADA network to provide information, for example, to your customers. Some of your commercial industrial customers has a number of maybe it's got a number of one or two substations providing information. This is providing power. This could be a good way of showing that information to them. The other one, I'm going to show you here two different dashboards related with the analysis of MI data. One is the customer load analysis, and the other one is the transformer load analysis. Customer load analysis takes into consideration the analysis of loads at customer level. Then when we start to aggregate the data from customer, we start to analyze the service transformers. So normally those transformers that are not sensorized, over which normally utility has got very little information. So we can start to provide information how those transformers are being loaded. And it becomes very important when we start to analyze, for example, the new loads that are coming into network related with the charge of electric vehicles. So let's see a bit in detail what we can do with this dashboard. One of them is voltage, for example, and power factor variation. Right? We have information coming from smart meters, residential smart meters, for example, and we can try to analyze the quality of power delivery. We're doing that by basically, for example, we can represent by aggregating different information from different meters very close to the substation and very far from the substation and somewhere in between. We can have the voltage profile of a feeder. So we can have a feeder head, and then we can have a mid feeder head and the end of the feeder, for example. So we can see if these three lines are very close to each other when they are very different, very, very separate from each other. It's basically a decay of voltage along the feeder. We can see how many times we have a voltage violation, and for example, we can spot the anomalies and when these anomalies occur. So maybe during the day we see that these are more frequent voltage violation in one section of the feeder, are more frequent in late at night or in the middle of the afternoon. And that's something that allows then a utility to take measure, for example, by placing a storage device along the feeder or a new load type changer, for example, to counteract against this voltage drop along the feeder. Another case that we're seeing, another case is the power factor monitoring. By monitoring power factor, of course, we can see whenever it goes down. In this case, we indicate at 0.9x, depending on which is the threshold that you want to consider. But that's also another way we can study and we can understand how the feeders are doing in the network. What we're seeing here is a load analysis. In this case, we're seeing load. We can, for example, suppose that we're seeing load at substation or down at customer level. We have the consumption compared to similar periods. of the past. So maybe we can see a load that is slowly increasing along the feeder. That means there's more appliances. Maybe there's some electric vehicles. There are customers have been deploying the years during along the feeder. We can see how much energy has been used during peak hour and off-peak hours. The distribution of load in the 24 hours of the day, when we can see the different blocks, how different blocks build up the entire consumption in a day. It becomes very important to understand when there is the highest demand at system level, substation level, or feeder level. And then we can compare demand versus temperature. How influent is temperature over the load of a system or a particular substation? In this case, we're aggregating to show the service transformer. So we're not going anymore. We're not taking the raw data from meters, analyzing meter by meter, but we are aggregating at service level, at service transformer level. Again, overload analysis, whenever the load of a transformer goes above 100% or above 90%, for example, the nameplate. The load distribution during the day, when is the transformer mostly loaded during the 24 hours of the day, or maybe the day of the week, the transformer is mostly loaded. Hourly overload distribution during the 24 hours of the day. We can review the historic load. So how many times that transformer, for example, has been for longer than three time intervals above 90% of its load. All this calculation can be run in the system. The algorithms are already there, but they can also be customized. Maybe you're not interested in the 3 continuous time interval, but you're interested in 5 continuous time interval. That's a parameter that we can, of course, change in the algorithms. Clustering analysis. This becomes very important when you're analyzing time of use rates and what's the effectiveness of time of use rates. So the algorithm basically runs clustering analysis across the entire population of meters. It spots different consumption profile. In a pilot that we did over 20,000 meters, by using 2 years of data, we found, if I'm not wrong, I think we found 10 different cluster profiles, which are potentially 10 different time of use rates, or 10 different commercial offers that can be done to customer to basically distribute those peak loads along the 24 hours of the day, and trying to avoid those to always hit the peak in a certain period of time. Forecast analysis, very important. By taking customer data, so metering data, and forecast information of weather measurements, we are able to forecast the 24 hours ahead up to a week ahead of hourly load at customer level, and then aggregating, of course, up to system level. Of course, the finer is the weather forecast information, the finer, the more precise would be the forecast that we can do. At this moment, I believe we are analyzing up to 5 different variables. I think we're doing temperature, humidity, we're doing wind, speed, even wind direction, if that is available. We're doing humidity. Then we're also using the period of the year or the period of the week. So basically the day of the week. All these variables all these variables have influence somehow on the overload, on the overall load of the system. And we're trying to understand what's the influence of which one of them. And this is done by the forecast analysis module that you see here. We also have a way of, once the forecast algorithm forecasts flow, then we have an internal system to control the error. And of course, if we see that this error is constantly increasing, then we can retrain the algorithm to reduce the error compared to the real measurements. It becomes very important having the 24 hours ahead, the hourly load 24 hours ahead. Of course, it's a very important information for the control center to organize switching, for example. If you use that information together with your most loaded feeder, then you will know, for example, that you want to divert part of the energy flow into other feeder that are less loaded than the very loaded ones. And so all this information can be given 24 hours ahead up to 1 week ahead. The further away we go in time, of course, the less precise the forecast will be. And as the date gets closer, then it will be more precise. And then let me go on into, this is the asset technical data module. So what we're trying to represent here, okay, we talked about data, how is data organized? We have templates for different kind of assets. We can generate an asset tree with all the different levels. So from system to substation to feeder to transformer bank, feeder circuits, etc. We can go down to the different ID devices, so ID along the network. As long as you want to represent a component that has got some kind of data feed that you're interested in, this can be built into the application, can be represented. Once it's here, we can create templates. For example, so if each time you will create a new substation, you will know already there's a number of data points that will be taken from the SCADA, for example. Or each time you create a new transformer bank, then there's a number of data points that will be coming from SCADA or from other systems. But this also gives you the possibility to add technical data, for example, the make and model or the year of installation of a transformer. And that allows then the analysis of the data by searching or by using that particular technical characteristics. Another window that I really like, another display, is this live data from power plants. In this case, some of you are distributors, some of you are also, of course, in the generation part. So if you want to use the same system to take data from the grid as well as from a power plant, this is the right system for you. And here we're representing a hydro plant. This is a hydroelectric plant, and we're taking real data coming directly from the field. Some other data will be calculated. We can be represented this very finely, all the different measurement that we want. For example, in this case, would be temperature, would be currents, would be voltages. So think about that. This is not only for your SCADA data, for your typical feeder information, but also for your storage. For example, if you have batteries that you're using, if you have solar farms that are connected to your network, this could be a way of understanding how those are performing, and also a way to show to other parts of the company which do not have access to the OT network, how the system is performing. And then the last one is live data again from power plants. In this case, what we're seeing here, this is a wind farm that we're seeing information coming directly from the wind farm, and this is a more general view, for example, of a solar farm, how the solar farm has been performing in a certain number of time period. I wanted to show also the data acquisition module. We're going a bit technical here, but the idea is the data acquisition model, which is the first part that we're seeing in the diagram before, is where data is coming in from the field. So we have already a number of industrial protocols implemented. We have IoT protocols here. We have directly connection with rational databases. We have file format which are already available. So whenever we say, okay, we are creating a technical database of technical characteristics of assets, we can take that information for example, from your asset management system. We can take coordinates from your GIS system. We can take data directly from other databases or directly from the field, for example, through Modbus. So there's really a plethora of possibility to import data automatically into this system. So it's not only a flat file interface, it's also a very dynamic and real-time interface. The configuration of the data acquisition model is all graphical, so there isn't really need to program. It's drag and drop. We kind of here what we're doing basically is configuring imports, but also configuring kind of controls and quality check of the data before data is stored in the system. Briefly going into the value. So summarizing basically the value, there's a number of accelerators in terms of data collection, data processing, portability. We can interchange databases. We can contextualize data. So if data comes from SCADA, it's not only SCADA data, it can be used for maintenance, can be used for planning, can be used for engineering, can be used for troubleshooting. The way once data comes in, that's where we contextualize data. We put data inside different context, different domain, so that then other system or in the same system, different worker groups can work together. And then there is the data visualization part. We're mostly used to see data in kind of spreadsheets and then the classical table. But think about rather than downloading and then working with your Excel, start to think about having dashboards which are dynamically adaptable. You can scroll back and forth in terms of time frame. You can overlap one to the other to basically compare different magnitude and different signals. So all these things are the accelerator that we see in Onesait Intelligence. And then before I finish, let me go, what's an intelligence quick start, for example. Again, here we are representing a project which can take like a proof of value to understand which are the use cases that you mostly are interested in. You can see the ones that are already available out of the box, and you can create new ones. For example, between 1 and 4 months, I would say around 4 months probably, we can start to have data coming in. We can import some of your historical data that you have and start to show you information or reorganization of the information you already have stored. Then once you're satisfied, once you're familiar with the use cases, then we can do a ramp up. We can start to create those data feeds, that automatic data feed from systems. And then, of course, in the next 5 to months 12, then basically in the next 8 months, we can consolidate that. So we can ramp up and have more data coming in, more use cases. We can increment and improve the data, the analytic models, and then the consolidation part. That's when you start to change processes in the company, because you're seeing the effects of, you're seeing the value of data. You're seeing how things can start to be steered so that the process improves. I will stop here now, and if there is any question, I'll be happy to answer them. But just 2 minutes, yeah.
Yeah, there is a couple of questions that came in. The first one is, how are changes in the network handled by the system?
Good question. We have this question a number of times. So what happens probably where, I believe this refers to, what happens when we configure the system with all the substation and transformer banks and feeders, and then the network basically evolves, extends. There are some new SCADA points. Whenever there is a new SCADA point available, the interface will basically notify that there is a new available SCADA point. And that is, then the company can basically create immediately. You don't really need programming, and anyone can basically going to any point of the tree that you were seeing before and just say add an element, then select from a template the element, and the element, once the template is chosen, then associate the new measure to available, the new data points available to SCADA with the data inputs in the element. And starting from that moment, the system will start to get the information and store it. The processing of the information will be the same. Once we create, for example, a basic voltage, let's say, once we create the energy signal coming from one of the feeder, and automatically the system will generate the aggregate information from the substation. This is part of the template. When we create the template and we create the processing, the pre-processing of data. Is there any other question, Leah?
Yeah, we got one more week at time for. Can all the historic data of SCADA be used in the system?
The answer is yes. We'll have, of course, to see, depending on how far back we have to go. It's not a matter of time. It's a matter of how data has been stored in the past. If that data is coherent with the new data model that is developed today. But in general, let's say if a signal is 5 years old and has been providing information, providing data for the past 5 years, we can just upload it into the system. And when we upload, that's when we do the pre-processing part. For example, we want to calculate average, daily average, or weekly average, or the maximum, minimum. All that information, if we have, for example, 15 minutes data and we want to understand which has been the maximum, the minimum during the day, that's all done by the pre-processing part when we import data during the data migration. And great. I believe we're just over time, which is 1 minute over time.
That's perfect. Thank you, Giovanni, and thank you, Leonor, for joining us. Even though we didn't have any questions specifically for you, we do appreciate you taking the time. And thank you, everyone, for joining today's session. As a reminder, if you're looking for any past sessions, those are now available as on demand in the sessions menu. So that's where you can find anything from earlier today or yesterday. And also do be sure to visit the exhibitor area for additional products and solutions. These sponsors are the reason we were able to bring you this super cool interactive virtual conference at no additional cost. So make sure you go over there and show them some love. And that's it. We will see you tomorrow. Thanks. Bye, everyone.
Thank you.